If you have been in a couple of our sessions these past couple of weeks, I think you would have noticed a theme by now that we've been riding this wave of ontologies and addressing it through its different levels and taking different approaches to understanding it, one, but also in the application of it across different contexts. And the goal today, again, is to adopt a similar approach and to kind of set the groundwork for where we're going and to take a different angle to this session. So yeah, as you can see, today's session is titled How Ontologies Turn One Model into Three Outputs and Living Documentation. And our current and I think a prominent understanding of what documentation is that it describes a system after decisions have already been made. We will have a system that is designed, then it's built, and then it's deployed, and then someone comes along and they write about what that system actually does. And so what we see is that by the time that the documentation is complete, something has already changed. And so what I want us to explore today is whether there is a fundamentally different approach, right? Can a single domain model, either expressed as an owl or a turtle ontology, drive three distinct outputs simultaneously, and where we can see visual UML diagrams and structured documentation and working code kind of implemented at the same workflow level. And so we're going to trace that path from a natural language requirement to a deployed application. And we're going to see how keeping the ontology as the canonical source means that documentation is not only just written about the system, but it is developed from the same model as the system itself. And that's the central claim of this discussion as a whole, and is what we will be walking through. So just to give a brief overview of what we'll cover in today's discussion, we'll first start off with the starting point. And this is where I want to ground us in a real scenario, looking at a lived experience of what happens to documentation within an enterprise, whether this is in a data department or an engineering department, and how that changes over time. And so we'll look at the pattern of decay, put some numbers to it, and also talk about what it actually costs an organization when the documentation can't be trusted. And this will then lead us into why documentation rots or why it decays, right? So why does documentation always fall behind? What is it about the way that we build software that makes this outcome almost inevitable? And critically, what happens when you layer AI on top of stale documentation? And so the takeaway here is that this is a structural problem and not necessarily just a discipline one. And structural problems need structural solutions. Our next session then brings us onto one model with three outputs. And this is where we introduce more concretely the alternative. So instead of maintaining documentation as a separate artifact, what if it was generated from the model that also produces the diagrams and the code itself? And we'll look at ontologies at a high level here and explain what they are, how they connect to UML diagrams, and ultimately to a running system. That then sets us up for the living part, right? What changes when the model is the documentation? And this is the core shift today. Today, when you have a business rule that changes, or someone that updates the code, or someone else that updates the test, and then everyone hopes that a third person remembers to update the docs, this is a problem that can kind of have quite prominent consequences later down the line. So we'll look at how can we adopt 4 steps or 4 opportunities for drift in this approach. And in the ontology-driven approach, you make change in one place in the model, and the code, the diagrams, and the documents regenerate from that single source. Then from there, we will walk through both workflows side by side, so we can see exactly where the manual steps disappear and why this makes documentation accuracy a structural guarantee rather than a team discipline problem. From there, we take a step back and we just look at where the industry is heading. Look at a couple of organizations in the space, Palantir, Microsoft, and developments within MCP capabilities, as these aren't small signals, but what we are seeing is that the biggest platforms in enterprise software are converging on ontologies as infrastructure. And then we bring it home to what we've been building on ecosystem code, with 2 big updates being the business domain repository and our ontology-driven generation. And we'll show how these tie back into everything that we've discussed. And then we'll close with a couple of concrete examples within industry, because again, none of this matters if it doesn't solve a real problem for a real team within a real domain. And to lay the ground in this case, I think we need to address something quite specific, because simply saying that documentation goes stale is an easy thing to say, but quite a hard thing to feel unless you've been the person on the other end of it. So when I say statements like ship, I mean the moment a system goes into production, and not when a feature branch is merged, not when a pull request is approved or anything of that sort, but rather a point where real users are interacting with the system, where real data is flowing through it and real business processes depend on it. And that's when the clock starts ticking on documentation accuracy. And when I also say documentation, I'm talking about the full surface area. I'm talking about API contracts, architecture diagrams, data dictionaries, entity relationship models, business processes, descriptions, onboarding guides, right? The Confluence pages, the wiki articles, the README files, the Swagger specs, all of it, right? Every artifact that describes what the system is, what it does, and also how it works. And when I say sprint, I'm talking about the 2-week delivery cycle that most enterprises operate in. Each sprint introduces changes, new endpoints, updated schemas, modified business rules, or deprecated features. And each one of these changes creates a gap where the system can drift from what the documentation actually says it does. And when a system launches, what we tend to see is that documentation accuracy tends to be about 100%, right? The team has completed a build, the tech writers have done their parts, diagrams were generated from the final design, and everything aligns. But what we can see by sprint 12, which can be roughly 6 months in, is that you've shifted maybe 15 to 20 features, right? The documentation is now about 70% accurate. And why does this happen? Because 2 or 3 features per sprint shift without a corresponding documentation update can cause this. And it's not necessarily because anyone was outright negligent, but because the sprint commitment was to deliver working software, and the documentation was treated as a follow-up task. And those follow-up tasks tend to accumulate. And what we then see by sprint 12, which could be about a year in, we have that accuracy dropping to about 40%. In most cases, what we see is a developer that changed the data model and updated the code, but not the API docs. And so we can also have the wiki page for the billing module that describes a workflow that hasn't existed for the past 4 months. And these are occurrences that happen quite prominently. And this pattern tends to be predictable, right? Every sprint without a documentation update increases the gap, and every gap increases the cost for the next change, because the next developer then has to figure out what is true before they can figure out what to build on. And the debugging cycles get slower, right? Regression errors increase because people are working from incorrect assumptions. And so the question then becomes whether the architecture of how we produce documentation makes this outcome inevitable. And the answer, I personally argue, is yes. And how do we then address this? How do we then adopt an approach where we can limit the impacts of this and kind of take an approach that forefronts this entire output? And I think the next stage then leads us into how documentation rots, right? So now that we've seen that what the pattern looks like and what it costs, it's important to understand why this happens, because it is a structural problem. And the pipeline that most enterprise teams follow is that they start with a requirement, and then maybe someone writes a user story, you have a product brief or a business case, and that then becomes the design document, and maybe even a technical specification or an architecture proposal or a set of UML diagrams. And the design is then handed to engineering, right? They then write the code, and then after that, the system is built and tested. And so these are 4 steps in that chain where you have requirement, design, code, and documentation. And documentation tends to be always last. It tends to be the final step within a linear process, which means that it carries all the risk, right? So if the sprint runs long or documentation gets cut, the developer or finishes the feature on the last day of the sprint, there's no time left to crafting these documents. And if a requirement changes mid-sprint, the code gets updated before the documentation update goes into the backlog. And this then sits there until someone gets into it, which in practice means that it sits there indefinitely. And this creates 3 very predictable problems. The first is that it tends to be out of date quite prominently. So when documentation is a trailing indicator, or when it's written after the fact, by the time that it's written, the thing it describes has already moved on. And you can't manually keep a copy synchronized with a thing that changes every 2 weeks. The second conflict that we tend to see is that conflicts with reality, where the documentation says that the customer endpoint, for example, returns 5 fields, when the actual endpoint returns 7. A developer reads these docs, they build an integration based on these 5 fields, and discovers in testing that the API behaves differently. And that's not a documentation problem at that point. It becomes a productivity problem within the system. The third that we see is that nobody knows what is current. At this point, the team has stopped trusting the documentation entirely. They don't check because they know it's probably wrong. New team members are told, you know what? I mean, that becomes the culture. You've lost the documentation entirely. It's still there. It's definitely consuming storage and it shows up in search results, but it's worse than no documentation at all because it looks authoritative while being wrong. Now, here's where these intersects with AI and where it becomes a systemic intelligence problem as a whole and not just a documentation problem. What we see across the board in enterprise teams is that they are deploying AI assistants and co-pilot tools that need to reason over this internal documentation, right? They feed these system docs, the API specs, and simple architecture descriptions into these tools so they can help developers move faster. But if 52% of enterprise AI responses contain fabricated information, as research has found, then the AI isn't simply just hallucinating because the model is flawed. It's also hallucinating because the documentation is reasoning that it's reasoning over is stale. And so what we see is that stale documentation actively misleads the tools that we're building on top of it, right? And where you can have a case where a developer asks an AI assistant, what does this endpoint do? The AI that then pulls the documentation that's 6 months out of date, and it gives a confident, detailed, wrong answer. The developer then goes ahead and builds on that, and the bug then only surfaces 3 weeks later in production. This then prompts us to reach for alternative approaches, where if documentation is generated from the same model that produces the code, and the model is the ontology, then the documentation cannot be stale. It can't be stale because it's not a separate artifact that is maintained in a separate timeline. It's a view of the model. It's regenerated every time the model changes. The AI assistant that reads it is reading the documentation that reflects the current state of the system because both the docs and the system came from a single source, right? Which leads us to the view of having one model with 3 outputs, because this is where the mechanics matter most. And it's important to understand that how models typically work in enterprise systems today is that you have a requirement document that describes what a system should do, where you can also have a design artifact, maybe UML diagrams, architecture diagrams, or entity relationship models that describe how it should be structured. And from those, then you have the code base, which is the actual implementation, and you have the documentation as well. And so these are 4 separate artifacts that are maintained by different people on different timelines with different tools. And the requirements, for example, could live in a platform like Jira or Confluence, and you can have the design documents that live in a Lucidchart or a Miro. And so the fundamental problem is that none of these artifacts are derived from each other. They are all manually created, they're all manually maintained, and they all drift independently. And so what this creates is a systemic level of a lack of a canonical description of the system, right? Where there is no single place you can go to answer the question, what is the system exactly? You have to cross-reference 4 different sources, hope that they all agree, and make a judgment call when they don't. And from our discussion in the past couple of weeks of what an ontology is, to give a brief overview of it, it can be understood as a formal description of a domain, right? It describes the concepts that exist, the relationships between them, and the rules that govern them. It's not the code, it's not in the documentation, but rather in a structured, machine-readable format that both humans and tools can work with. And if you've ever drawn boxes on a whiteboard and connected them with arrows to explain how each system works, you've done this informally. An ontology, on the other hand, is the formal version of that whiteboard drawing, and it uses a standard structure called OWL. And from this, we then also have the fact that the ontology also defines your domain concepts and relationships. And by domain concepts, we mean things like customer and order and product. How do they relate to each other? What properties do they have? What constraints also apply in that case? And from that definition on ecosystem code, you then head on over to generating a UML diagram where the classes in the ontology become the boxes in the diagram. The relationships become the arrows. The cardinality constraints become the labels on these arrows. Now, UML diagrams are not entirely, but can be understood fundamentally as graph models, right? They describe the nodes and edges, entities, and relationships. And so when you look at a class diagram, you are looking at a graph of your domain. And the ontology is that same graph, but in a format that carries the semantic meaning and not just the visual layout. A UML diagram, for example, can tell you that this customer connects to order. The ontology then tells you that customer places order, and an order must have one customer in that case. And so the semantics travel with the model. Another understanding that we can adopt from this is that from the same ontology, you can generate structured documentation to provide an understanding of what is a customer, what field does it have, what relationships does it participate in, what constraints apply, right? This documentation is generated text and it's not written text. It describes the model, and because the model is the source, the documentation therefore remains current. And this then becomes quite a critical point, right? Where the documentation exists before the code itself is generated. In a traditional workflow, documentation tends to be the last step. The ontology produces the diagram and the documentation becomes available from that. And from this, it becomes evident that documentation can be a precursor to the implementation process and not just simply an afterthought. And this is then what we mean when we say documentation is living, right? It's not living because someone is diligently updating it, but rather that it's living because it's generated from a model that is the source of the truth. And so where you change the model, and all three outputs, these are the diagram, the documentation, and the code themselves, also regenerate. And this then results in nothing being forgotten because nothing is being maintained manually. The documentation cannot drift from the system because they are both views of the same thing, which then connects us to what ends up being the output. And these three panels show us that there are three generated views of the same ontology, where on the left, for example, you have a diagram that shows how a customer is connected to an order through places order as the relationship with cardinality constraints that are visible. And this is the view that architects and designers within enterprises use during reviews. It's the structural picture of how everything connects. And importantly, it's not a manually drawn diagram that someone has to update every time the model changes. It is generated by the system itself, where you change the model, the diagram therefore regenerates. In the middle, we have documentation. In ecosystem code, the flow is that documentation is available before you actually generate the code. And so why does this accessibility matter? It matters because it reflects fundamentally the different relationship between documentation and the system. In a traditional workflow, documentation describes the system after it's built. Here, documentation describes the model before the code exists. It tells you what a customer is, what fields are required, and what an order contains, what the relationship between them actually means. And this is the view that business stakeholders use, and this is what analysts review. This is also what auditors check, right? And so when we say that documentation is living, it ties back directly to this point. The documentation exists as a generated output of the ontology. And it's not a wiki page that someone wrote 6 months ago, but it's rather current, and it's an actual description of the model itself. And then on the right, we have the code, which has the classes with type properties and constraints. And so the question then becomes, what are the implications of having a systematic workflow like this? Well, firstly, it changes our understanding of onboarding, right? When a new developer joins a team today, they spend 2 or 4 weeks reading outdated documentation, asking colleagues for context, or reverse engineering the code base to understand what the system actually does. And instead of that approach, with generated documentation that is current, this can be changed quite rapidly. The new developer instead can just read the documentation that matches the code, and they can start contributing immediately. The second is reviews, right? If you have, for example, architecture reviews or design reviews, all of these depend on accurate documentation. And when the documentation can't be trusted, reviews then also become quite untrustworthy, where you have people sitting in a room looking at diagrams that don't actually reflect reality and that are making decisions based on information they know that might be wrong. And when the documentation, on the other hand, is generated from the model, the reviews that are conducted can be more current, there can be an accurate representation of the system, right? The diagram on the wall actually matches the code in production. Thirdly is for the purpose of audits, right? If, for example, if you're in a regulated industry like banking, auditors need to verify that the system behaves according to its documentation. And so when the documentation drifts, audits become painful, where you can see teams scrambling to reconcile what's documented against what has been deployed, right? And with documentation that is living, the audit trail then is inherent. The docs always reflect the model, and the model drives the code, where there is nothing to reconcile. Fourthly, we have AI and automation. So if you're building RAG pipelines or AI assistants that reason over your system documentation, the quality of the output depends entirely on the quality of the input. And so generated documentation from a living model means your AI tools are reasoning over current and accurate information. And this connects directly to the wider flow of ecosystem code. And as we can see over time, is that the platform takes you from words to UML to the running code, where you paste an epic and user story, and the platform then generates from that. And the ontology layer then sits between these design and generation. Your diagrams adopt the structure, and the ontology adds governed semantics and roles on top of that. And so when the roles in the ontology are confirmed and the code generation emits a permission manifest, middleware and seed users, the generated application enforces the authorization that is derived directly from the model. And so what comes out isn't just 3 passive artifacts, but rather 3 interconnected views of a governed domain model, right? Which then takes us to what this actually means in practice. On the left, you have the traditional workflow where you add a new business rule, where you have step 1 where you update the code, step 2 you update the test, step 3 where you remember the updated docs, step 4 where you hope that someone actually does it. And we've all been through this, and we all know how step 4 is where it falls apart. On the right, however, you have the new workflow where you have step 1 where you can add the rule to the ontology, and step 2, the code, the diagram, and the docs regenerate automatically. And that's it. 2 steps instead of 5, and 1 arrow instead of 4. And that then becomes the whole point. When the model is the source of truth and everything is generated, there's nothing to forget to update. The documentation can't go stale because it's a separate artifact. It becomes a view of the model that is regenerated every time the model itself changes. And this is an ontology-based approach that combines domain information and software engineering knowledge to produce documentation that evolves along with the system. And for us to understand this quite clearer, it's also important to understand where the industry is heading. And you may think that it's quite niche, but this has some of the biggest platforms in enterprise software that are converging on this exact idea. For example, you have Palantir that just launched Super Repo in August 2026. And this is an ontology that is ontology as code that is written in TypeScript, where you build full stack applications anchored to an ontology. And what they've exposed is that the ontology exists through the MCP, which means that external AI agents can reason over your business model directly. And that is a massive signal. One of the most important enterprise platforms in the world is saying the ontology is the center of your application. Secondly, we have Microsoft Fabric IQ that has introduced what they call an ontology item. And this sits at the center of Fabric, and it connects data, processes, rules, and actions. And it can bootstrap from those. And they're building no-code tools so that business users can work directly with this platform. Then there's Model Context Protocol that we've come to understand as the standard for connecting AI agents to structured data. And Anthropic started this, and it's now backed by organizations like OpenAI, AWS, and Google. And MCP in this case has become the pipe, and ontologies are the thing that flows from it. And so what we see from this is that the direction is clear, right? Ontologies are becoming the interface between business logic and AI agents. And this is not simply a research exercise anymore, but it's something that is embedded within the infrastructure. So, which then begs the question, what are we doing about this, right? What is the approach that we're taking as the team at Ecosystem Code to make sure that we are also at the frontiers of these events? And so while these big platforms are building out their ontology infrastructure, we've been working on the same principle at the workbench level inside Ecosystem Code. And here there are two important things to highlight at the moment. Firstly is that the business domain repository is a curated catalog where you can browse and apply domain definitions across your project. And in this case, you're not just starting from a blank page, you're selecting definitions that have already been modeled, tested, and refined. And so this connects directly to the one model that we spoke about, right? The repository gives you a head start on the ontology that then drives your 3 outputs. Secondly, we've also had a stronger ontology-driven generation, right? We've tightened the connection between the domain context in the ontology and what comes in the generated application. The model isn't just used for documentation. Instead, it's actively driving the code that gets produced. When the ontology changes, the system reflects it immediately. And that's the living documentation principle in practice. And so what this ends up meaning is that you are not starting from scratch, right? You are simply, instead of just simply saying, okay, cool, that sounds great, but how do I actually get started, right? Do I need to know how ontologies function? Do I need to build in or incorporate an ontology of my own? And we simply say no, right? That's what the domain catalog serves. You have structured domain catalogs where each domain ships with these 3 layers. And within that, there are controlled vocabulary, which is agreed upon language for your domain, right? So for example, you can have a shackle completeness that shapes and which are validated rules that tell you whether your model is accurately complete. And this is something that is handled for you when you approach that stage, right? And every domain is also organized around 7 standing headings. These headings being concepts or taxonomy, relationships, attributes, life cycles, roles, and also primary workflow, right? This gives you a consistent structure. Whether you're working in banking, insurance, or telcos, you are able to pick your domain within the project wizard, and those entities and relationships are then loaded automatically. This then also connects to source mapping, right? This is how you connect existing systems without replacing them. A source mapping then becomes the translation layer, right? And different source systems can integrate through the same domain vocabulary, even when their table and column names are completely different. And this mapping doesn't make the schema canonical. It doesn't replace the ontology. It just states how physical structures represent canonical meaning. So you can bring your existing databases into the model without actually rewriting anything. And so this catalog is open source and it is available on our GitHub on Ecogenetic Organization. And if you want to take a look at it over there, right? And for us to understand the shift and how it's happening, it's important to take a bit of a zoom out and look at the bigger picture in this space. We have the old world where business analysts write your specs, or a developer builds the system, or a technical writer documents it. And then you repeat the whole thing every time something changes. You have 4 different roles with 4 different handoffs with 4 places where these things can fall out of sync. But in the new world, you have a domain expert or a developer that collaborates with the ontology. The system, the documents, and the diagrams are generated outputs, and changes flow through the model and not through a chain of manual updates. And so the statement then is, instead of you wanting to leave, the model is the documentation and not the other way around, right? In the old model, the documentation describes the system after it's built. In the new model, the model describes the domain and the system is generated from it. The documentation then becomes a byproduct of this and not simply a deliverable. And so from this, it's also important to understand where documentation can become the bottleneck. And it's important to also make this concrete by looking at a couple of industries or a couple of scenarios where ontology-driven generation has a pretty high potential to change the outcome. So firstly, for example, in banking, where you can have a core system that's built for migration, right? You've got 5 CRM systems that need to be consolidated, where in a traditional project, project, 80% of the effort goes to mapping and hacking the data. The documentation describes systems that no longer match the reality of what the system has become in the years that those CRMs have been in production. And so every integration decision is based on guesswork. However, with an ontology-driven approach, you define the target domain once and generate the API contacts, the entity models, and the migration docs from the same source. The legacy billing logic lives in tribal knowledge and outdated wikis. However, with ecosystem code, you're able to capture the billing domain in the ontology, and the UML diagrams, the code scaffold, and the documentation are then generated from that, where you can then see onboarding dropping from just simply being a matter of weeks to something that happens in days, because the documentation is more accurate. In the case, for example, of an industry like insurance, where regulatory compliance is a big thing, and compliance documentation and system behavior can drift apart more prominently. And this is something that is picked up on when audits are conducted, and you see teams scrambling to reconcile what's documented versus what is actually deployed. And with an ontology-driven approach, the ontology encodes the rules, and the generated docs always reflect the current model, because the audit trail is inherent in the system as a whole. So what changes when the model changes itself? And so we've talked about banking, we've talked about telcos, we've talked about insurance in detail, but where else does this apply? Well, in short, you can see this: the cost of stale documentation exceeds the cost of modeling, and the bar is lower than most people think. So for example, financial services, regulatory compliance, KYC flows, or documentation that needs to be accurate for legal requirements, this is something that fits into that quite prominently, right? And domain ontologies close that gap by giving AI agents a formal understanding of what a system actually does, right? In the case of, for example, enterprise ERP systems, where there can be a multi-vendor integration through your bigger enterprise providers such as SAP and Oracle that have the master data management approaches, 80% of this transformation effort is in mapping, and ontologies reduce that directly. Or for example, in healthcare, where you have patient data models and clinical workflows and interoperability standards, these are life science ontologies that are captured through systems that already provide the foundation layer. Or in the case of governments in the public sector, where you have policy implementation or citizen services or cross-agency data sharing, where this needs to align with the public sector interoperability mandate, right? The application of ontology in this can be contextualized to fit the current state, but also how it was built from the beginning, but also the needs that map onto the modernization standards that are to be set going forward. Awesome. With that being said, I hope this gives quite a prominent picture of how one model can contribute to these different outputs and how documentation can become a living artifact of systems. If you would like to explore this further, Ecosystem Code has a full outline of this, and you can see ontology-driven modeling in action. Like I said before, the domain catalog is open source and it's available on GitHub if you would like to take a look around. And yeah, that is most of it from me. Thank you so much for listening. If you have any questions, happy to take them now. Awesome.
So I've got a question from an ecosystem code perspective, but also from an ontologies perspective, right? So I'm just curious about the skill level required. Now, something that vibe coding has done is it's opened up the doors to a lot of people into the coding space, but there's still a lot of obscurity within that. But with the vibe coding work, I've been doing quite well, actually, except that, like you keep talking about, things keep changing. Right? I'm trying to find a more formal approach to setting, like, for example, rules in Cursor, or setting some kind of like really kind of structured background or structured entryway to it. Now, when you're talking about ontologies, you're talking about ecosystem code, to me, I'm going, this makes total sense. It's like a taxonomy, right? You are categorizing things, you're listing things. I can do that 100%. But how technically difficult is this actually?
I would argue that it's not as technically demanding as you would expect with resources and tools that come at this level. And I say that because the provisions that we've made on the workbench is to provide a catalog of these ontologies. So we've productized them, or packaged them rather, in a way that can reflect whatever system you are trying to build. And because it passes through these different stages where the ontology needs to be reflected in the UML diagrams, and then in the documentation, and then in the code, that then becomes ways that it constantly checks that it actually maps onto what Jessica said she requires from the system. And I guess the goal is, at the end of the day, to make sure that the descriptions that are shown to you are in a way that are easy to understand, but also can be changed in a way that reflects your level of understanding.
So you would then, do you write, I mean, and maybe this question could be targeted to Graham as well, and to both of you, but do you manually write your own ontologies, or do you generate them? And is there not potential for inaccuracies if you are going to generate them? So you would spend, I mean, you're basically shifting the nature of the work that you're doing then, because you're going to need to spend a fair chunk of time writing out your ontology, and then you would go and generate your MCPs based on the ontology, or would those be side by side?
Do you want to take this one?
Yeah, I think, Jessica, the short answer is you can have inaccuracies whether you write them or generate them. That is one of the challenges. Mostly people are trying to generate them, and people are trying to reverse engineer them from existing systems, existing database schemas, corpuses of documents in organizations, process mining, all sorts of things. And that works up to a point. But you still need some sort of domain or subject matter expert review to make sure that those concepts make sense. I think you can define the structure relatively easily. That's kind of what people understand in business and what people have been doing in data modeling for years. I think the tricky stuff comes with the axioms, the constraints, defining stuff that is machine provably correct. That requires a whole different level of skill. Okay. All right. I had a question. I don't know if there are other questions, so I'm happy to wait.
No, please go ahead, Brian.
Okay. Two questions, actually. The one is around that. How much are you defining in the ontology? Is it purely structure? I see you've got a process or workflow component, and you've got a business rule component. I'm presuming constraints and workflow go in those. But what about things like UI and stuff like that?
I think it will definitely depend on a case-by-case basis, depending on the scale of the system as a whole, right? So if each domain, like I said, is organized around the 7 headings of concept, taxonomy, relationships, attributes, life cycles, the depth of this will definitely depend on the scale of the system. So for example, if you're building a CRM for a enterprise that has already existing structure set up, and it has a way that it connects these different points and the relationships between them, and you want that to be embedded, that will then also be a factor to consider. Or if it's in the case of a fresh CRM that is specific to a specific use case, and it's not leaning on an existing background of data, then this then also can change it. So, right. So you're defining things like what a customer is and how that relates to data. And the ontology then carries this through the different layers of the vocabulary, right? The controlled vocabulary, and then also the machine readable structure, and also the validation of these that can fit into that. Yeah. So I would think of it in that way. But of course, this is not a defined or confined understanding of this. Yeah.
Okay. You mentioned embedded capability there. Can you, from the generated system, can you call capabilities in other systems via APIs or services or in some way? Because often what you want is you actually want to implement some kind of process over the top of other capabilities.
I think I wouldn't be able to give a concrete answer at the moment, but I would highly assume that it depends on the embedded capabilities of the system that you are building. So how you've constructed it to function within production would be a factor that can be drawn into this case, and also what the external points are. So if, for example, if it's a CSV or a SQL, I think this is something that also would then factor into that. Yeah.
Okay. And then the other question was, if I am going to be generating multiple different systems, but I want them to be in one organization, and I want them to be consistent in terms of architecture, style, etc., can you create some kind of sort of house style that is shared across those different systems?
Definitely. This is something that we've been working on quite a lot, actually, to have that enterprise level where different teams can work from the same ontological architecture and structure so that the rules are set in place. So this would definitely be an enterprise capability and integration that is manually set up for you by us in a way that can reflect that. And even how ecosystem code then responds to the different departments will then definitely be set out in a way that there is that understanding across the different systems, but also there's continuity in the fact that, okay, if one thing changes in this specific department with this specific element, this is then also reflected, taken into consideration across the board. Yeah.
Okay, those were my questions.
Any other questions?
I think that's it from everyone.
Thank you all so much for joining.